Today we're going to do ogives and group data. Cumulative frequency. In a survey of urban crime, 200 inhabitants of a city were asked the number of times they had been victim of street crime in the preceding 5 years. Here's a frequency distribution of the number of incidents. So for 0 to 3 incidents, we had a frequency of 154. For 4 to 7 incidents, we had a frequency of 24. For 8 to 11 incidents, we had a frequency of 18, and for 12 to 15 incidents, we had a frequency of 4. So that total frequency is 200. What are the classes and what is the typical class width? Then compute the relative frequencies of each. So the classes here are the number of incidences: 0 to 3, 4 to 7, 8 to 11, 12 to 15. The width of each of these classes, also known as bins, are 4. Compute the relative frequencies of each. To compute the relative frequency, we have to take the frequency over our total number n. So our first relative frequency would be 154 over 200. The second one would be 24 over 200. The third would be 18 over 200, and the fourth would be 4 over 200. Now with the cumulative frequency, we would add the previous frequency to the preceding frequency. So our first cumulative frequency for 0 to 3 incidences would be 154 over 200. But for 4 to 7 is cumulative, so we would add 24 to 154 and get 178 over 200. Then the next we'd add 18 to the 178 and get 196 over 200. And then lastly, we would add 4 to 196 and get 200 over 200. You would use this information to make a cumulative frequency polygon, also known as an ogive. Take note of the following. The last entry in the cumulative frequency columns is 100% because it was 200 over 200. The frequency column will always add up to n, which is 200, and the relative frequency column will add up to n over n. Let's look at skewedness from the shape of an ogive. So you will have different shapes, and you will need to know by looking at the shape of an ogive if it's skewed left, right, or symmetric. If the ogive is concave up and just continually going up, it's skewed left. If it's concave up, has a point of inflection, then concave down, it's symmetric. And if it's concave down, going up, it would be skewed right. An ogive is a cumulative frequency curve. You will not be asked to produce an ogive, but you will need to know how to read one and answer questions. The questions will often involve finding the median, IQR, and fences for outliers, and it is possible doing a box plot. Ogives show up on the exam. Example 1, Derby speeds. Derby speeds in 2007. How fast do horses run? Kentucky Derby winners top 30 miles per hour, as shown in this graph. The graph shows the percentage of Derby winners that have run slower than each given speed. Note that few have one run in less than 33 miles per hour, but about 86% of the winning horses have run less than 37 miles per hour. A cumulative frequency graph like this is called an ogive. We need to estimate the median winning speed, estimate the quartiles, estimate the range in IQR, create a box plot of these speeds, and write a few sentences about the speeds of the Kentucky Derby winners. I want you to take a moment, pause this video, and try to do A through E on your own. First, to find the median, it's about 36. What you would do is this is our percentage, 0 to 100. 50% is about here. You go out to your graph, and then you would go down, and the median is about 36. Next, our lower quartile is at about 25%, which is about here on the vertical axis. Go out to your graph, and you go down, and our lower quartile would be about 34.5. You would do the same thing with your upper quartile. You'd go up to about 75%, go out to your graph, draw a vertical line down, and that value down there, about 36.5, would be your upper quartile. So, like we said, our median speed is about 50%, which was about 36. Our lower quartile was about 34.5. Our upper quartile was about 36.5. To find our range, our max was 38, because if you look here and go down, that would give you 38. And our min was 31, so our range was 7 miles per hour. Our IQR was about 2. Here we have a vertical box plot. And then we said the distribution of the wind and speeds in the Kentucky Derby is skewed to the left. The lowest wind and speed is just under 31 miles per hour, and the fastest speed is about 37.5 miles per hour. The median speed is approximately 36 miles per hour, and 75% of the wind and speeds are above 34.5 miles per hour. Only a few percent of winners have had speeds below 33%. And if you look at that, notice the spread at the top half is a lot smaller than the spread at the bottom half. Let's look at example 2, cholesterol. The Framingham Heart Study recorded the cholesterol levels of more than 1,400 men. Here is an ogive of the distribution of the cholesterol measures. An ogive shows the percentage of cases at or below a certain value. Construct a box plot of these data and write a few sentences describing the distribution. Please pause the video now and try to complete a box plot of this data by using the ogive to find the minimum, the maximum, the lower quartile, upper quartile, and the median. First, we're going to start by finding the min and the max. The minimum value over here and the maximum value over here. So I'd say that's about 100 something and about 400 something. Next, we're going to find the lower quartile, which is about 200. Same thing, you go to your horizontal axis, find about 25%, go out to your graph, and go down. That was about 200. Our upper quartile is about 260. Went up to 75%, go to my graph, draw a vertical line down, and it was about 260. And then my median was about 230. So with the box plot, I have my ogive, 100 being my min, 200 being Q1, 230 being my median, 260 being my Q3, and 425 being my maximum. The distribution of cholesterol levels is skewed to the right and tightly clustered around the median. The median cholesterol level is approximately 230, with the middle 50% of cholesterol levels between 200 and 260. A very small percentage of men had cholesterol below 150 or above 325.